Hello, geometry students. This one's nice and short today. I'm going to look at similar figures and how their areas are related. Quick review of similar figures. So here's a couple of triangles that are similar in the obvious way. I want you to take a couple of minutes and work out the unknown lengths. So pause here just for 2 minutes so you can jot this down and work out those unknown lengths. All right. So let me remind you that the ratio of lengths that we know is called scale factor between the similar figures. So this is length 12, corresponds over here with length 24. So that establishes the scale factor between these two triangles, and that of course reduces to 1/2. You could turn it upside down and do 24 to 12, which would be 2 to 1. You just have to be consistent. The scale factor is simply a ratio of lengths of corresponding triangles. And so, how are we going to get these other lengths? Well, we're just going to set 1/2 equal to the corresponding ratios. Pretty straightforward. I'm pretty confident you got to this. 8 over x has to be 1/2. That means x is 16. Y over 10, those are corresponding sides, also has to be 1/2. That means y is 5. Pretty straightforward. Now, what about the areas? Are the areas also in a 1 to 2 ratio? And the answer is no, the areas aren't in a 1 to 2 ratio. They're in a ratio, but it's not 1 to 2. Take a look here. Here's one of the squares. I left some graph paper on there. In the original figure, there's one of the square units in its area. When I carry this over to the other figure, it doesn't turn into 2 squares, it turns into 4. When you grow the figure, when you go from the smaller one to its larger cousin over here, you doubled the lengths. You also doubled the heights. And since area, you're going to be multiplying these dimensions together in some way. In this case, it would be 1/2 base times height. Since you doubled this and you doubled this, both of those multipliers come into play. And so instead of multiplying the area by 2, like you did with the lengths, you multiply the area by 2 squared. You multiply the area by 4. And the general principle is that when you have similar figures, their areas are also in a certain ratio, but it's not the scale factor. It's the square of the scale factor. You have to square this 1 to 2 ratio here to get the ratio of the areas. So here's a little example I'll work with you. 2 trapezoids are similar. Complete this chart. So I'm going to complete this chart here. So I've got smaller and some information, larger trapezoid, here's some information. Now notice here, shortest base, longest diagonal, height, those are all lengths. So the scale factor is a ratio of lengths. So the scale factor is going to be the ratio of each of these pairs. And we know this pair over here. We know 4 over 10. So that establishes the scale factor between these two figures. The scale factor is 4 over 10, which is 2 over 5. So now we're going to use that to figure out these other unknowns here. Let me give them names. I'm going to call them x, y, and z so that I can use them in equations. Since these are all lengths here, this is a length, this is a length, I can just use the scale factor. The scale factor is the ratio of lengths, and these are lengths. So that means x over 18 is 2 over 5, and 6 over y is 2 over 5. The scale factor being 2 over 5. If I cross multiply and solve these, I can do these in my head. X is 36 over 5, y is 15. So, but what about the area? Well, area is not length. So that means you're not going to be able to write z over 150 is 2 over 5. That would be incorrect. This is a scale factor. That works for lengths. This is area. What we saw on the previous slide is you have to take the scale factor and you have to square it. This is the correct equation. Z over 50 ratio of areas is scale factor squared, 2 over 5 squared. And 2 over 5 squared is, of course, 4 over 25. And when you work this out, you get z has to be 24. And that's it. That's the whole lecture for today. It's really short, and I'm going to keep the homework short. Tomorrow, you'll have a practice quiz. I don't think I will be back tomorrow, but you'll have a practice quiz, and the solutions to the practice quiz will be posted on a video in the same location you're able to find all the other videos for this class. So you can check your work, and I'll annotate and talk through the answer to all the things on the practice quiz. And then we'll do a quiz on this area unit on Monday. So, but that's all. Have a good day. I'll see you later. Bye-bye.